Hey guys, we're going to move on to 5.2, lesson 5.2, which we're going to be talking about properties of rational exponents and radicals. So let me present my screen and we'll get started. All right, so the vocabulary, I'm going to put in the vocabulary for you guys so we don't have to take the time to write it during the video. But simplest form of a radical, you should know this from Algebra 1. So basically, under a radical, you can't have any factors other than 1 that would be a factor of the nth power, so no perfect nth power. So for instance, if it's a square root, you can't have any square root factors under the radical. If it's a cube root, you can't have any cube root factors under the radical. You can't have any fractions under the radical. You can't have a radical in the bottom of a fraction. I think that's it. I think I covered them all. All right, conjugate, we've talked about conjugate this year, and then like radicals. So like radicals are radical expressions with the same index and the same radicand. So the same little number out in front, like square root, cube root, fourth root, and what's under the radical has to match as well. All right, here we have our properties of radicals. I'm not going to take the time to read every single one of them because I'll be explaining them as we go through the problems. But make sure you take a few minutes and just like look at the definition and then look at the example and make sure they make sense to you, because we're going to be using all of these different properties in the problems that we're going to be seeing in just a minute. All right. And then we also have properties of radicals, which again, some of this should be reviewed from Algebra 1, but take a look at the definitions and take a look at the examples. I'll be using these two properties, the product property and the quotient property, as we work through the examples, okay? So for the example, let me zoom in, by the way. I'm just noticing now that I didn't zoom in. Make it a little easier for you guys to see. There we go. So use the properties of radical exponents to simplify the expression. All right, so for the first problem, what you're going to first do, there's sometimes these problems, or oftentimes these problems, can be approached in different ways. Okay, some steps have to be done before other steps, but in some situations, you could do this step or that step. So for example, I could first use properties of radicals and rational exponents to make this exponent positive. So I could drop the entire thing under a 1 if I wanted to. All right, but I'm not going to do it that way. I'm just showing you that is one option. How I would approach this problem is I would first apply the exponent outside to the exponents inside. We're going to multiply them. All right, so you have 2 to the third times negative 1/3, and then times 3 to the third times negative 1/3. So 3 times negative 1/3, that's going to be 2 to the negative 1 times 3 to the negative 1. All right, now I'm going to drop and make the exponents positive. So it's 1 over 2 to the first times 1 over 3 to the first. So that's really just 1/2 times 1/3, which is going to give you 1/6. Okay, for the next problem, because we have the same base, our exponent rule, this has an exponent of 1, our exponent rule is to subtract the exponents. That's one option. Okay, so one option is you write down the base and then you subtract the exponents, 1 minus negative 4/5. Okay, that's one way of doing this problem. Another way to approach the problem is to move this up, and when you do that, instead of a negative exponent, it becomes positive. Because remember, anytime you move, it changes the sign of the exponent. So it becomes 10 to the first times 10 to the positive 4/5. Now, because the bases are the same, our exponent rule is to add the exponents. So it's 10 to the 1 plus 4/5. All right, and that's going to give you, let's make it actually 10, instead of 1, I'm going to make it 5/5 plus 4/5, right? Because 5/5 is equivalent to 1. And now you can see that it's 9/5. 10 to the 9/5. That's your answer for 2. For number 3, okay. So for number 3, what I'm going to do is I'm going to apply this exponent on the inside to the outside to the ones on the inside. So I'm going to multiply. So I'm going to have 52 raised to the 5/6 over 4 raised to the 5/6. Now, unlike the last problem, see here how the bases are the same. The bases aren't the same here. So I can't just subtract the exponents, all right? But because your exponents are the same, you can divide, because what you can actually do when the exponents are the same, you can write it as 52 over 4 raised to the 5/6. Think about what we did over here. When there's an exponent outside, don't you just apply it to the exponents on the inside? And right now on the inside, they both just have an exponent of 1. So if I multiply, I'd be back here with what I have. But by doing this, by rewriting it with the 1 exponent on the outside, now I can divide. 52 divided by 4 is 13. So I have 13 raised to the 5/6. And that's that. All right. For number 4. So I see none of the bases are the same. Okay? None of the exponents are exactly the same. I have 1/3, 2/3, 4/3. All right. I'm trying to see if anything could be simplified. I haven't had to simplify anything yet, but I'm wondering if, let's see, if I rewrite these in radical form. So it's the cube root of 3 raised to the first, that can't be simplified, times the cube root of 27 raised to the second, divided by the cube root of 8 raised to the fourth. All right, well, the cube root of 3 raised to the first, you can't take the cube root of 3, that doesn't simplify. But the cube root of 27, that does simplify. That simplifies down to just a 3. Okay, so this first one, I'm actually going to rewrite it again as 3 to the 1/3, put it back into the form it was. And then the cube root of 27 is 3, so now I have 3 squared, over the cube root of 8 is a 2, right? 2 times 2 times 2. So that's 2 to the 4th. Now by doing that, now I have the same base up top, so I can add the exponents. You write down the base and you add the exponents, 1/3 plus 2 over 2 to the 4th. Oh, I'm running out of room. All right, now 1/3 plus 2 is going to be 7/3. So it's 3 raised to 7/3 over 2 to the 4th is a 16. And that would be your final answer there. Okay. All right, let me delete this. It says, find simplified expressions for the perimeter and area of the figure. Well, it's a square, and we know to find the perimeter, you take the sides and you add them all together, or since all the sides are the same, you can just write it as 4 times the side, which is 4 times 10x to the 1/4, which you can just multiply the 4 and the 10 together to get 40x to the 1/4. That would be your simplified expression for perimeter. For area, to find the area of a square, we do side times side, or we often write that as side squared. Since the side is 10x to the 1/4, we're going to square that. So using properties of radicals, the 10 has an exponent of 1, even though we don't write it. The exponent on the outside gets multiplied with the exponents on the inside. So it's 10 squared times x, and then 1/4 times 2 is 2/4 or 1/2. And then 10 squared is 100, so it's 100x to the 1/2. And that would be your area expression. All right, let's keep on moving along. All right, use properties of radicals to simplify the expressions. So for number 6, all right, so since we have the same root, we have a root 6, you can simplify that and write it as the 6th root of 25 times 625. Well, 25 times 625, if you use a calculator, okay, you can do it without. I would need to use a calculator or write it all out. Get 15,625, all right, which is actually 5 to the 6. So the 6th root cancels with the exponent 6, leaving you with just a 5. Right, for number 7, they are both under square roots, right? Square root of 343 square root of 7. So I can rewrite this as the square root of 343 over 7. Right now I'm doing that because they're not perfect squares, so I couldn't simplify them the way they are. But is this divisible? 343 divided by 7? It is. It's just the same thing as the square root of 49. The square root of 49 is simply a 7. All right, so that's 7. For number 8, you have the cube root of 25 times the cube root of 10 all over the cube root of 2. Okay, so in the numerator, since they're both cube roots, I can rewrite that as the cube root of 25 times 10 to get 250 over the cube root of 2. All right, now because they're both cube roots, I can rewrite it as the cube root of 250 divided by 2. Now I want to do it that way because 250 is divisible by 2. 250 divided by 2 is 125. 125 is a perfect cube. Okay, if you need to do your factor tree, do it off to the side. You're going to see it's 5 cubed. 5 times 5 times 5. The cubes cancel, and you're just left with, you're just left with a 5. All right. Numbers 9, 10, 11, and 12. For number 9, write the expression simplified form. So doing your factor tree, by breaking that down into the factors, you're going to have 2 to the 7th, right? 2 times 2 times 2 times 2 times 2 times 2 times 2, and then times 3. Okay, so you can rewrite that as the 7th root of 2 to the 7th times the 7th root of 3. The 7th root of 2 to the 7th cancels, it's just a 2. So it's 2 times the 7th root of 3. And that would be your simplified answer. For number 10, okay, you can't take the cube root of 5. You can't take the cube root of 9, right? But you're not allowed to leave a fraction under the radical. So what you're going to do is rewrite it as the cube root of 5 over the cube root of 9. Now, 9 is the same thing as 3 times 3. So let me write that out for a second. 9 is the same thing as 3 times 3, or 3 squared. I don't want 2 3's under there. I really want 3 3's because then it can cancel. This is called rationalizing the denominator. You're going to multiply the top and bottom of the fraction by whatever you need. And you can do that because it's an equivalent fraction as long as you do it to both top and bottom. I'm going to multiply it by the cube root of 3 because if I had one more 3 under here, right, then you'd have a 27, and that is a perfect cube. So now I have the cube root of 15 over the cube root of 27. The cube root of 27 is just a 3, so now I'm left with the cube root of 15 over 3. And that would be your final answer for that one. 11 and 12, you're going to multiply by the conjugate for these. All right, so to get the radical out of the denominator, you have to multiply top and bottom by the conjugate. And we know from earlier this year, the conjugate is 4 plus root 5. So I'm going to multiply the top by that and the bottom by 4 plus root 5. You're going to want to put this in parentheses because you actually need to FOIL. All right, distributing the 1 in doesn't change anything. So that's just 4 plus root 5. But your denominator, when you FOIL, 4 times 4 is 16. 4 times root 5 is a positive 4 root 5. Negative root 5 times 4 is a negative 4 root 5. And negative 5 times positive 5 is negative root 25. All right, so I have 4 plus root 5 over 16 minus, these cancel, and root 25 is just 5. So I have 4 plus root 5 over 11, and that's your simplified answer. Right? And the next one is similar to this. Multiply top and bottom by the conjugate. So the conjugate is going to be 1 minus root 6. 1 minus root 6. So distribute the root 2 in. So it's going to be root 2 minus root 12. FOIL the bottom. So it's going to be 1 minus root 6 plus root 6 minus root 36. Root 2 cannot simplify. Root 12 can, right? 4 times 3. So that simplifies to 2 root 3. The root 6's cancel, so you're left with 1 minus 6. So you have root 2 minus 2 root 3 all over a negative 5. And that's that answer. Okay. Like that. Now these last 4 examples. Scroll down. All right, I'm just going to probably do 2 of them. I'm going to give you the answers to all of them. The answer to 13 is 38 cube root. Oh my goodness, let me try that again. 38 cube root of 5. Number 14, the answer is 0. Number 16, the answer is 147 z square root of z all over x squared. And number 15, the answer is 3/4 root of x squared all over 2x to the 9th. Okay, so I want you to try these. They're writing the expressions in simplest form, assuming that the variables are all positive. For the first one, it's simply like radicals. When you have the same index, the cube root, and the same radicand, 5, you just work with the coefficients. Think of it if it was like negative 2x plus 40x, right? The x's don't change. You just work with the coefficients, and it's negative, not negative, it's positive 38x, right? It's the same idea here. You just work with the coefficients. It's called adding like radicals. Negative 2 plus 40 is a 38 cube root of 5. So that's all I had to do for the first one. For the next one, all right, you may want to rewrite these as 2 and then the 4th root of 1250. See if that can be simplified. Minus 5 times the 4th root of 32, and see if that can be simplified, which they can be simplified. And then you're going to be left with like radicals to combine. Okay, same thing with the next set of problems. Try to simplify and see what kind of cancels out and see if you can get the answer. So I want to give you guys those problems to try on your own. You have the correct answers to verify. If you have trouble with them, you can always jump onto a 12th period with me and I can work through them with you. All right. So that is it for that lesson. I'll see you back here for the next one. Bye.